Hi everyone, I'm Helen. Welcome to my channel. In this video, I'd like to introduce how to compile OpenSees. Now let's get started. This is my downloads folder, and you can see three software installers here. And the first one is Miniconda. It is used to configure your Python environment, and also the TQL and TK is included in the Miniconda package. The second one is a community version of Visual Studio. Here I downloaded the 2019 version, but the latest version is 2022. I think both versions will work well to compile OpenSees. And the third one is the Fortune compiler. If you have an Intel processor, then you can go to the Intel website to search for Intel Fortune compiler, and then you can download this installer. So first, you may want to install the Miniconda first, and your Python environment will be there. And then you will install the Visual Studio community version. So after you double click it, it will evaluate your system and then give you a dialog here. I have already installed the community version of 2019, so here appears to be a modify. Click on it, a dialog is shown to you, and you will have to configure what functionality is included in the Visual Studio. So here we just use this one, desktop development with C++. It is enough to compile OpenSees. And then if you haven't installed it, it should be install or update or something else. Here for me, it is a close button. So after installing the Visual Studio, then you can install the Fortune compiler just to follow all the steps. So these are all the prerequisites to compile your OpenSees. And then let's go to github.com, look for OpenSees/OpenSees. This is the exact source code repository of OpenSees. If you're familiar with Git, then you just clone this repository into your device. If you're not familiar with Git, that's totally fine. So basically speaking, Git is a version control system. So every commit will be stored in its repository. And here, under this selection box, you can see a tags tab here. And you can see there are several tags which are milestones for the development. Now let's go to tag 3.3.0. And the repository will trace back to earlier time point when the 3.3.0 release was released. So here, go to code and then download zip. You will see that download started at once. It will take a few seconds to download all the source code. After download completion, you will find a zip file in your downloads folder. Then you can unzip it, extract here. So the OpenSees 3.3.0 source code is here. Okay, now let's go inside the repository and go to Win64 if your device is 64-bit, and then open OpenSees.sln. Double click it and Visual Studio will start up. So here in the Solution Explorer, you can see that Solution OpenSees consists of several projects. And the project we are going to compile will be OpenSees, which is the TQL interpreter, and OpenSees Pi 38. So although we don't compile the other projects, they are related to OpenSees, which you can find them here. So that means if you compile OpenSees, then the other projects will also be compiled. Here, something you have to pay attention is that you have several choices of the compiling. So currently it's debug.dll, which compiles a DLL file, but we want to compile an executable file. So let's switch it to release. And then let's try right-click on OpenSees and build. And you can see that the program starts to build all the files that are needed for OpenSees. Here, while the compiling is in process, I'd like to thank Professor Michael Scott for uploading a video on how to compile OpenSees. This video was fully inspired by his video, and because that video was a communication, which was quite a long time, so I want to just focus on all the key points in compiling OpenSees, so I created this video. So to compile a C++ project, there are two main things that you have to keep in mind. The first one is that you have to specify all the paths for the header files, which are .h files. And the second thing is that you have to link all the library files, which are .lib files. So you have to specify all the paths for the library files. So if you have given all the correct paths for all the header files and library files, then the project will be successfully compiled. So it took a while to compile all the files, and now we can see there are some errors, which are all cannot open include file tcode.h, which means that we haven't specified the path for tcode.h. Now let's try to find the path. So as I mentioned, Tico was installed together with Miniconda. So let's go to the Miniconda directory and go to library, maybe. Under library, click include, and you will find, yeah, this tcode.h and also all the other tcode related .h files. So now what you have to do is just to copy this path and then go back to Visual Studio, right-click on OpenSees and Properties. In the C/C++, there is an additional include directories. You have to add the directory to this. So here at the bottom of the list, you can see program files /tcl, which cannot find tcl file here because our file system is different from others. So we just include what we just copied here. And then click OK. So for OpenSees Pi 38, we do the same thing. Properties, C++, and include directories. Add it to the bottom and click OK. Okay, then we try to build again. Visual Studio configures an incremental build, which means that the files we already successfully built will not be built again, so it saves a lot of time. Okay, the compiling finished, and we can see that still tcode.h cannot be found. That is because we only specify the include path in OpenSees project, but for other projects, we didn't include that path, so they still cannot find the tcode.h file. Now let's do a hack. I just select all the tcode started.h files and copy them, and then go to our source file. So this path was already included in the additional including paths. So we just paste these .h files here. And then let's build again and see what happens. Okay, the compiling is done, so there is no longer tcode.h errors, but there is another error which says cannot open input file if console.lib. This library file is related to the Fortran compiler, so we have to find the path of this lib file. So let's go to where Fortran was installed, C program files, Intel, one API, and then compiler, and Windows, maybe lib. Sorry, go back. It should be compiler and lib and Intel 64 Win. So you can see a lot of lib files here. To make the Fortran code be compiled, we have to include this path. We just copy this path, but now we are specifying the path for lib files. We go back to OpenSees, properties. This time we go to linker, and there is additional library directories. We can edit it and paste the path here. Okay. And also OpenSees Pi, we do the same thing. Linker, additional library directories. Paste. Okay. And then let's see what happens. Okay, still tcode 86t.lib cannot be found. So let's go back to Miniconda again. Try to find tcode 86t. I think it should be in the library and the lib. Yes, tcode 86t is here. So let's copy this path and add to the linker again. Do the same thing for Python. Okay, build again. Now you can see that build 1 succeeded, which means that you have already successfully built it OpenSees tcode interpreter. Let's go back to the downloads folder, go to OpenSees Win64 and go to bin. You will find OpenSees.exe here, which is the compiled executable file. So let's test it. Right click on the folder, open Windows Terminal, and then type in /OpenSees. Here we go. You can see this is exactly what we just compiled. Okay, let's close this file, close this, and then compile OpenSees Pi. Okay, here is an error. Python.h cannot be found. So let's look for Python.h. Go to Miniconda, include. Let's see if Python.h exists. Yes, exactly, it's here. So we add this include here into the include directories. Okay. Sorry. And try again. Okay, still a lib file is missing, which is Python 38. Let's go to libs. Yes, Python 38 is here. Let's copy the path and specify it in the linker. Okay, and build again. Here we go, succeeded. Let's go to the downloads folder, back. Here you can see an OpenSees.pyd file. So that means we can import it from Python. Let's try it. Open in Windows Terminal and type in Python. We go into the Python interpreter and we type in import OpenSees. That looks fine. So we try OpenSees.model. See what happens. It gives an standard error, which asks you for NDM and NDF. That concludes that OpenSees works fine with Python. So this is the end of this video. I hope all of you can successfully build your OpenSees. Thank you. Goodbye.